Okay, this is the helper video for lesson 3, growing dots. So we're going to start off with the retrieval, so the ready. Use the tables to find the indicated value. So we're going to zoom in real quick. Find f of 5. So 5, right, is our input. So we're trying to find what is the output when our input is 5. So we're going to go along the top here, right, and look for the point right here where our input is 5, and we see that that goes to an output of 12. All right, so f of 5 is 12. All right, let's switch up the colors a little bit, right, just for the next one. Let's see. All right, f of 9, right? So for number 9, we're going to go over here. We're going to say, what is the output? Well, the output is 32. All right, so f of 9 goes to 32. Now find n that goes with f of n equals 22. So this means that there's some number, we'll switch colors again, there's some number n where if we plug it in, we're going to get 22. All right, so let's look in our f of n column, right? Because we know that f of n equals 22. We look across and it looks like it is right here, right? And that happens to go with 7. All right, so we'd write n equals 7. Right? And then we'll switch up the colors one more time. Let's go to a blue. Find n that goes with f of n equals -3. All right, so if our function, right, if the output should be -3, it looks like that happens right here. Right, what is the input? Well, the input is going to be this 2, so n equals 2. All right, that's number 1 complete. Number 2, find g of 3. All right, so we've got a completely different function now. Instead of f, we're working with g now, our function g. All right, so find g of 3. All right, so if our input is 3, we're looking here, and our output seems to be 6. So g of 3, oh, sorry, messed that one up just a little bit. There we go. G of 3 equals 6. Perfect. Find G of 8. All right, we'll switch colors. G of 8. All right, so if our input is 8, our output seems to be 29. All right, so G of 8 equals 29, negative 29. Sorry, not 29, negative 29. All right, find n that goes with g of n equals -1. All right, so if our output is -1, we'll do this one in green. That looks to me like it's right here. This is our output equal to -1. So our input that goes with that output is 4. All right, so we'd write n, our input, equals 4. Find n that goes with g of n is -43. All right, we'll switch up our colors one more time. We'll go back to orange, and we'll say, okay, we're looking for an output of 43, and we find that way over to the right. So there's our -43, and it looks like if we plug in 10, right, if our input is 10, we'll get -43. So n must be 10 in order for us to get -43. On to number 3. In the first table of values, how does n differ from f of n? In other words, what do n and f of n mean? Well, we actually talked about this a little bit while we were solving, but n is our inputs, right? So n is an input, while f of n is an output. Okay, so we're moving on. So if we plug in our n value into the function, we'll get out something, right? And that function is f. All right, so n, those are our inputs, and f of n are the outputs that come from our inputs of n. So they're sort of paired up like that. All right, let's keep going. Top of the next page. Number 4. All right, if you have a table of values like those above, they're to the left right now, but that's okay. And you can find the value for f of n. how would you go about finding the value of f of n minus 1? Okay. So if you can find the value for f of n, how do you go about finding the value of f of n minus 1? So this is actually saying you could, if it's a table like the ones before, right, and we'll go and look over at them again, right, if it's like these ones, you can see that our n values, like 1, 2, 3, 4, 5, 6, 7, right, they're all in order, right? So 1, 2, 3, 4, etc., right? There's nothing skipped, right? There each is one more than the one before. So you could, right, and that's as you go left to right. So you could go to the column, right? You could go left by one column or go minus 1. But more generally, right, we'll go back to here. More generally, what you can do is just take the previous value, right? So f of n, f of n minus 1 is the previous output. Oh, messed that one up. There we go. Is the previous output. Which is easy to find if we have a recursive function. All right. So f of n minus 1 is the previous output. We'll finish that up by saying the previous output to f of n. Excellent. All right, moving on. For problems 5 through 8, create the missing equation for the sequence based on the table, the description, or the given equation. Then decide which equation will help you find the missing term of the sequence most efficiently. Find the term and explain your choice. All right, so recursive, right? So our recursive form is now equals previous term plus 3. So whatever our value is right now, it's the previous term, and then we add 3 more. So if our term is 4, that means we'd go back to 3. Our previous term was 16, right? 3 went to 16, so we could add 3. So our explicit equation, it wants us to find the explicit equation first, which is fine. We can do that. So our explicit equation, it looks like we have 10 to start, right? On our first go, we have 10. We do start with 10, but it seems like we're going up 3 each time. So we're going to have y equal, or sorry, not y equals, silly me. We're going to have, should we call this one f? Yeah, we'll call this one f. That'll be okay. All right, so we're going to say f of n equals, it looks like we're going up by 3 each time, so that's 3n plus, what would we start at? If we had n equals 0, what would we be at? Well, it looks like we'd have to start at 7, because when we add 3 one time, we should be at 10. So 3n plus 7. And it's definitely easier to use the recursive on this one since we have the previous step. So if the previous step was 16 and we're going to go up 3 from that, our missing should be, right, our fill in the blank should be 19. Right, so find the value of the 4th term. That's going to be 19. All right, and our explanation is recursive is going to be easier. Right, and all we need to do is add 3 to the 3rd step. Or the 3rd term, I should say, right, to the 3rd term. Oop. There we go. Add 3 to the 3rd term. All right, let's move on to number 6. For number 6, all right, we have an explicit equation, 4n plus 6. F of n equals 4n plus 6. Now, our first term is 10, our second term is 14. We don't have our 3rd, 4th, 5th, etc., and it looks like we want to find our 50th. So, our recursive is going to be now equals previous, I'm not going to write this all the way out, previous term plus, what are we adding? Well, our second term was 14, which is 4 more. than the first term, so it's going to be plus 4. So now equals previous term plus 4. Find the value of the 50th term. Well, we don't know what the previous term was. We don't know what the 49th term was, so we can't use our recursive. But we can use the explicit 4n plus 6. All right, so if we know that n is 50, right, 4n plus 6, 4 times 50 plus 6 should give us 206, right? 200 is the 4 times 50, and then plus 6 should be 206. All right, so you should be able to like fill that in here, 206. All right, and now, the explanation. So we want to use the explicit because we don't have that was bad. Sorry about that. We don't have the 49th term. Right, so it makes it really difficult to find the 50th term using recursion if we don't have the 49th term. And in order to find the 49th, we need the 48th, and we don't have that either, so we'd have to find 47th, 46th, and so on. So we'd have to do a lot of work to use recursion in order to find the 50th term. So we'll just use the explicit. That will save us a whole lot of time. Nothing left on this page, so we go over and up. Here we go. So this is number 8. We're skipping that one. Down all the way. All right, here we go. Instructions. Evaluate the function to determine the output. All right, evaluate the function to determine the output. So we have f of n is going to be in purple, and g of n is going to be in green. I always like to make g of n green if I can, because g and green, right, that works out. So I will take suggestions on what color to make f of n all the time so that it's consistent. I don't know if a good color that starts with f exists, but we'll work on that. So where was I? All right, so number 11, we need to evaluate f of 2. All right, so we're going to be working in purple then. F of 2 is going to be, remember, when we have f of a number, we're just going to plug that number in wherever we see n, right? So this becomes 3 times 2 to the n, which just becomes 2, right? 2. All right, so 3 times 2 to the 2. So our order of operations says, and we've gotten a lot of practice with this, we always do the exponent first. So 2 to the 2 happens first. So this becomes 3 times 2 squared, which becomes, that looks like a little z, which becomes 3 times 4, right? Because 2 to the 2 becomes a 4. So 3 times 4, and then we get 12. Okay, so we have f of 2 is 12, and now we have g of 3, so we're working in green on the second one. So g, the function g is 8 times 5 to the n. 5 to the n, where n equals 3. So now we have 8 times 5 to the third. Now, we might know that 5 to the third, we might know that off the top of our head, but we might not. If we don't, we could do out the long division. But I happen to know that 5 to the third is 5 times 5 times 5. Well, 2 of those would be 25. 5 times 5 is 25. Times 5 one more time is 125. So we're going to write this as 8 times 125. And that one might be a little bit tricky. We can do that out by hand. You know what? That one maybe is tricky, so we'll do that one out by hand. All right, 125 times 8. All right, 8 times 5 is 40, so we're going to bring the 0 down here, and the 4 stays up top. Oh, that doesn't look like a good 4, does it? There we go. The 4 goes up top. All right, 8 times 2 is 16, plus 4 is 20, so we bring the 0 down and a 2 up top. 8 times 1 is 10. 8 times 1 is 10? No, it's not. 8 times 1 is 8, plus 2 is 10. I was working faster in my head than with my mouth. There we go. So 8 times 1 is 8, plus 2 is 10. So we just write that 10 down, and we get 8 times 125 is 1,000. Okay. 1,000. Excellent. And we were all set with that one. And oh, that is the bottom of the page. So we're moving on to the next page. All right, our go, here we are. So let's read the instructions first. Evaluate the following equations when x equals 1, 2, 3, 4, and 5. Organize your inputs and outputs into a table of values for each equation. Let x be the input and y be the output. So before we even look at 13 or 14 or any of the rest, what I do notice is that 1, 2, 3, 4, 5, that's all numbers in order. So recursion is probably going to be the most efficient way to tackle this, because we can just take the previous step and do something to it. So it'll be easiest to build this table if we go step by step. So let's start with 1. All right. 3 times 4 to the x. That means 3 times 4, and we multiply it by 4 x times. So 3 times 4 just once would be 12, right? 3 times 4 times 4, that's going to be 3 times 4 twice. That is what's going to happen if we have an input of 2. So that's just going to be, we take the output from number 1, our first step. We're actually just going to multiply by 4, right? So we're going to take 48 in this case. Oh, 48, because that's 4 more. For number 3, it looks like we're going to take 48 and multiply it by 4, right? Because our outputs are going to get 4 times as big each time. So let's go with 48 times 4. If people can do that in their head, that's awesome. Not expected. But we can also use a calculator. We should get, I believe it's 192. 192. Now, we got to do one more. All right. Well, it's actually going to be 2 more, but that's okay. So 192. Got to multiply that by 4 to figure out what our 4th output is going to be. So let's see. Our 2 gets multiplied by 4. That should definitely end us with an 8. Oh. One moment. Got to get the lights turned back on. Okay, we're back. All right, so 192 times 4, we're going to have the 2 becomes an 8. That's fine. 90 times 4 is 360. So what should this one be? 768, I believe. 768. We can check that on the calculator. In fact, let's do that. We pull out a calculator here. And we do indeed get 768. All right, and then the last one, we could do this. You know what? It's good practice to do the long multiplication out, so we'll show how to do that. Let's do 768 over here times 4. All right, always good to practice this. 4 times 8 is 32, so the 2 comes down and the 3 goes up. We're done with the 8. 4 times 6 is 24. Plus 3 is 27, so the 7 comes down and the 2 goes up. We're done with that. And now 4 times 7 is 28, plus another 2 is 30. So we should get 3,072. We're going to write that down, 3,072. And then we'll check it as well. 768 times 4 is indeed 3,072. So we will continue on, but those are our 4 values here. Now, so number 15, the equation's right here, but it looks like the table is on the next page. So I've actually copied the equation to the top here already. So we're doing y equals -3 to the x. Now, I said that a little bit weirdly. It should actually be -3 to the x. Now, why would it be that? Because the negative sign is seen as multiplication, but the exponent happens first, right? Our order of operations says we do parentheses first, no parentheses, then we do exponents. So 3 to the x actually happens first, and then whatever 3 to the x is, we make it negative, right? We multiply it by the -1. So if we have -3 to the x, well, 3 to the 1 is just 3, and then we need the negative of that. So -3 should be our first value. All right. Then we can actually just take that 3, or that -3, and we just multiply it by 3 because we're going to have an additional 3 each step. So -3 on the first step, -9 on the second step, -27. Oop, that is not a 2 or a 7. -27, then -51. Oh, that's not a 1. -51. And finally, did I say -51? It is not -51. Somebody better have caught me on that one. It is -81. That's my mistake. And then finally, -243. All right, so those should be our values for number 15. And it looks like, last but not least, we have 17. If f of n equals 5 to the n, what is the value of f of 4? All right, so this just means, right, we've got this function here, f of n equals 5 to the n, and evaluating f of 4 just means plug in 4, right? Oop. It just means plug in 4 for n. All right, and when we do that, we would end up with 5 to the 4, which we did on the previous homework assignment, but we can do again, right? That is just 5 times 5 times 5 times 5. It should be a total of 4 of them. All right, and we know that that is 625. 625. We can do that on the calculator to check, but I'm very confident. All right, 625. And that wraps up this homework helper.